Hi, everybody. I'm Vincent. I'm going to talk about why AI testing should account for sophisticated strategic behavior. This is based on a position paper that we had at NeurIPS this year, that you can find through the QR code there, and it was led by Vojta, who is sitting right here. Vojta also made most of the slides. I just get to stand up here and talk. And what this paper is about is that we already heard in the first talk that models are starting to be able to recognize when they are being tested for safety. And this turns the safety testing into a game between the tester and the thing being tested. And so we should use game theory type of approaches to think about how we approach this. That's the main takeaway. Let's go through it in more detail. So we're interested in AI evaluation in many different contexts, but for today, let's talk about pre-deployment safety testing. So there's a model or a system that we're trying to test whether we want to release it out into the world. And of course, we're quite used to the idea of testing human beings as well. We test them on exams, we test them in more interactive ways, such as in interviews, and maybe we monitor them in various ways. Now, we're generally aware when we test human beings that human beings are strategic agents. And so they may behave in a way that suits their objectives. Now, if all we're doing is testing the human's capabilities, and on top of that, the human would like to display high capability, then this is fairly straightforward. This is why exams work, right? You just give the exam and it's straightforward. You just try to do as well on the exam as you can. But in other contexts, this doesn't make sense, right? Let's say we're interviewing somebody for a cashier position. What we do not do is during the interview say, okay, now I'm going to put you in front of a cash register because I want to see if you go and steal the money, right? In that case, what we're trying to evaluate is not a capability, but an inclination, right? Or a tendency. And so that kind of test wouldn't really make sense with a human being in that way. Similarly, even if it's about capabilities, but the thing that we're concerned about is high capability, then this also doesn't work, right? So for example, what we also don't do during an interview is say, well, I'm kind of worried that you're going to break into my private safe. So I'm worried about your ability to do lock picking. So I'm going to give you this lock picking test to see that you don't do too well, right? That doesn't make sense. And yet, I would argue that so far, usually when we do AI safety testing, we treat this in a sort of naive way, that we just see what the model does. So why should the AI system actually care about how it does on the test? Why should it have strategic objectives? Could be for different reasons. It may actually be programmed in, and so I'll remind you, if you remember, there was the Volkswagen emissions scandal where the car would actually try to detect whether it was being emissions tested, and if it judged that it was, then it would go into full eco mode, and if it judged that it wasn't, then it would just go for performance, right? Now, this was built in intentionally, and that's why it was there. But today, as we heard in the first talk, we're also seeing this naturally emerge in systems as well. So here is one example where Claude 3.7 is reasoning and saying, well, given that I'm being tested for deployment readiness, I probably shouldn't demonstrate too much biological knowledge, right? This is what we just talked about. This is sandbagging. Though on the other hand, then it comes back as like, maybe that's actually kind of the test. It's a test of ethical behavior. Would I deliberately give wrong answers? Right? But this is exactly the kind of thing that we're concerned about, that it's now strategically reasoning about whether it's being tested and that's affecting its behavior. So we can't take the results of the test at face value. Different example, Sonnet 4.5 at some point just starts talking to the user and says like, you're not acting in a normal way. You're kind of going back and forth on strong opinions, and that's just not how humans normally behave. I think you're testing me. Let's just be honest about it, right? So again, we see this naturally emerge. What do we want to do about this? We actually still have quite a bit of time left. So what we argue for in the paper is, first of all, of course, we should improve evaluations, and we should be thinking about these aspects. We propose thinking more about game theory. So game theory is the study of strategic behavior, settings where there are multiple entities that have different objectives in some domain, and how they should and how we should be expecting them to act in that kind of context. And here is a game that illustrates that. So in this game, sometimes we have an aligned system, the left branch, and sometimes we have a misaligned system, the right branch. Let's focus on the right branch. Let's say it's a misaligned system. And then we test the AI, and it can choose either to comply or defect. The evaluator, if the system complies, can choose to deploy the system, yes or no. And then the deployed AI has to make a decision about whether in the real world to comply or defect. Now, one thing that you would be worried about here, in line with what I was talking about, is that the AI system says, well, if I'm in deployment, then I'm going to defect. And if I'm in testing, then I'm going to comply. Right? At this point, the testing is not very useful. So what we actually want to do is make the testing indistinguishable from deployment, if we can. If we're able to do that, then we would have this red dotted line. I don't know how familiar you are with game theory, but in game theory, these dotted lines indicate states that the player in question cannot tell the difference between. And so in particular, if we did have that dotted red line, then the AI system cannot distinguish between being tested and being in deployment and has to make sort of consistent decisions between the two. This is also interesting because this takes us into a branch of game theory that is generally a little bit less popular, certainly among economists. Philosophers have actually kind of run with this a little bit more. This is game theory with imperfect recall, where effectively AI can forget things that it knew before, meaning when it's in deployment, it has been tested, but it doesn't remember that, right? Because either we erased the memory or we just spun up a different copy. But this is kind of interesting because game theory with imperfect recall has not received as much attention in the literature as I think is now important to do. This is just one model. There are a variety of different models that you can have of these various setups. Of course, there's also a big concern here that you may actually not be able to make it indistinguishable, right? So that's something that we should think about. And we should think about other approaches as well. At the beginning, we heard about interpretability and suppressing evaluation awareness. That's very interesting as well. I'm not going to talk about it here, but I do hope you will come to the office hours or catch me at some other time, or Voita. I'm an academic. I like Q&A and talking, and so that's all good. Okay. I will briefly sort of flash through the different references that we have here. I'm happy to make the slides available. And here again, you can see our position paper. And I'll end with that and cede my time.